sthMO is actually a very huge program at Stago because it means a complete change of our coagulation offer. You know our existing instruments, the max generation of instruments, Start Max, Satellite Max, Compact Max, and even the Star Max, the biggest one. We are changing this for a new proposal, for a new offer, that we will start with 2 new instruments, meaning new software, new hardware, new firmware, but also a new line of reagents. Okay. It means also that we have a lot of people, more than 250 people working on the project for several years. And the architecture, the main idea that we have when performing this new offer is to keep what makes the Stago offer strong, so keep our Stago legacy, while adding new features, adding new possibilities. The sthemO program will start with 2 new instruments, the sthMO 301 and the sthMO 201. sthMO 301 is equivalent to the StarMax and a little bit more, while the sthMO 201 is more equivalent to the Compact Max, in between Compact Max and StarMax. When we started to work on this project, we said to the R&D, we want something that will optimize the lab productivity, that will enhance user experience, and that will improve patient journey. The risk with that kind of very large words is that they can understand a little bit of everything or anything. So we try to make it a little bit more clear. We want an instrument which is designed for a continuous throughput, something that is easy to use, easy to manage, easy to handle, and that never stops, that you can perform tests at any time. Something that will use the current possibilities of algorithm, of artificial intelligence, things that was not existing when we built the max generation. So we want these new features to be embedded into our new offer. And since these instruments will be the future offer of Stago for the years to come, we want them to be ready for any additional changes, for any improvements that might come in the future. So they must include additional technologies that maybe today are useless, but then we know we will be able to implement new stuff in the future with these instruments. Some example, designed for a continuous throughput, it's a software which is very easy to understand. We are all used to use our mobile phone today, and honestly, none of us read the user manual to use a mobile phone. We want our software to be on the same idea. You should be able to use it easily, even without using the user manual. Not completely, but at least. Okay. We want an instrument which is able to get full continuous loading of everything without stopping the instrument. Okay? You want to load sample, you have space, and you can make it. You want to load reagents, this is the same. Washing liquids, solid liquid, solid waste oil, everything can be managed while the instrument is running. So you don't need to stop to make the maintenance, to stop something, to take care of the instrument. Easy to use, continuous throughput. And there are some images of how it looks like. Here is, for example, the loading of here's reagents. Here is samples. Okay, loading the cuvettes. Here they are coming without the beads, so you can load them. And then the waste, whatever liquid or solid, with a big tank that you can remove or refill without stopping the analytical cycle. Continuous throughput means also an instrument with a very large capacity. Okay. So for the 301, it's actually 126 position, and with different areas. So you can load here, unload here, reload here. Okay, you can always do something, and you will have enough space to make it. And there is a dedicated area for QC and calibrants, which needs to be refrigerated, so they are not in the same. No, they are actually refrigerated also. A way to make it simple also is to get self-agitated racks. Okay. Today, when you use the Optimal, for example, for a PT test, you have to put a steer bar, and at the end, you have not to forget to remove the steer bar to use it in the next vial. With this new instrument, actually, the steering position are managed by the instrument, and there is no need of steerer. Okay, so this is just performed by the instrument. No steerer, but agitation performed by the instrument. In terms of capability, in terms of capacity, washing solution today is a pack is a vial of 15 milliliter, which means that for high throughput laboratory, you need to change it several times during the day, and eventually you have to stop to be able to reload a new vial. With this new instrument, then you get a 250 milliliter package, which means that it's equivalent to more than 16 vials. Okay? And it is managed separately. So you have 16 times more capacity for the dissolve, and then you don't need to stop the instrument to remove it. Yep. Same, so for the loading of reagents, you have a touch screen. You just move it, say where you want to load the reagents. It opens the place. I will make it again. Okay, so you can see the touch screen. You say where you want to open. Automatically, the instrument will open the window to load the reagents, and then you just load the reagents. Same for the cuvettes. So now cuvettes are not coming with the beads, so you have to put the beads in a dedicated position. And instead of the roll of cuvettes, which is not always easy to handle, we change it with a pack of cuvettes. You just put it, leave it, and close the door, and that's done. And you can do it while the instrument is working. Okay, so that's just example of with a user-friendly and ease of use of the instrument. We've tried to, let's say, understand and hear what was expected on the next generation of instrument, and we try to improve it to make it easier to use. Then we want to take advantage of the current IT possibilities about algorithm, about artificial intelligence. So we have embedded some algorithm in our instruments that are based on self-based algorithm to be able to come with few features today, but we hope to be able to develop them in the future. The first feature we have available on the instrument is an automated brand recognition. Okay, meaning that you can put any kind of tubes, liner, sartet, whatever the type of cap. Okay, you can mix them all in the same rack. Actually, there is a camera. The instrument reads and recognizes the tube and automatically adapt where to make the piercing, the size of the volume, and when to pipe it. Okay. We have implemented an automated maintenance, making that you don't need to make the maintenance. You just have to tell the instrument at what time you want to perform the instrument. So basically, if you start working in the lab at 7 o'clock in the morning, let's say, then you can ask the instrument to perform the maintenance at 6:30. So when you arrive, the instrument made the maintenance, and you just have to tick on maintenance done. Another feature that we have embedded is about the traceability of the reagents and about the information we can provide on the reagent barcode. So instead of the regular barcode that we have on the max generation of instrument, we can now implement 2D barcodes. Okay? And this 2D barcode allows actually to get much more information into the barcode. So thanks to this new technology, then we are able to provide with the barcodes recalibration, lot number, shelf life expiry dates, okay, remaining volume, number of tests, and also all the QC values. Today, you already have all this information with the max generation. The only difference is that with the max generation, you need to read the barcode and then you need to scan the paper sheet which comes independently. The idea is just to make it easier to use, so you get the same level of information, but just by putting the reagent on board, okay, and it is scanned automatically. Something that we have added is what is called the vial identification number. That's something that we couldn't implement on the max generation, is that each vial is having a unique number, okay? Meaning that when you are using the vial number 1 of the optimal, and that you switch to a vial number 2, if for any reason you want to come back to the vial number 1, then the instrument recognizes this is the first vial that you already used 3 milliliters, okay, that you already used it for 4 hours in the instrument, and then automatically say, okay, the volume is not 5 milliliters but 2, and the onboard stability is not 8 hours but 8 minus the 3 or 4 that were used, so only 4. Okay, so that allows a much accurate traceability. Okay, this is what I said already, the automatic adjustment of the pipetting level and volume check of the different tubes. And this is managed automatically. You don't have to do anything. Actually, we train the instruments to be able to recognize the different brand and the different kind of tubes. And then it will also recognize the different tubes that you use. And so we'll manage it automatically. Something that we have implemented already with a dedicated software on the max generation that we have been able to implement on the instruments is algorithm. And the one that we are the most proud of actually is about the lupus anticoagulant testing. It was explained how difficult it is to follow the guidelines for the monitoring of lupus anticoagulants. We have actually performed an algorithm with Dr. De Vries, who is one of the most experts, let's say, about lupus anticoagulant detection. And we have developed an algorithm that allows you to follow the ISTH guidelines just automatically. You have to put the reagents on board, okay? You just put all the reagents, and you leave it to the instrument. And automatically, the instrument will perform PTTLA, the LAD screen, will check the values. If one of them is positive, we'll continue to this one. If it is the other one, we'll continue to the other one, okay? And we make it step by step, all the steps, to finally provide you a final answer saying lupus positive or lupus negative, check for factor deficiency, check for something else, okay? But then you get the algorithm, the complete algorithm, and directly with the answer. And then we want an instrument that will be ready for the future. Today we are using chronometric detection methods with viscosity-based detection system. This is one of the Stagó legacies. This is the heart of the detection system for clotting tests at Stagó. This is a gold standard, so we continue to use it. We want to be able to come with new improvement, new possibilities. So we put a photometer with 12 wavelengths, to be able also to measure immunoturbidimetric and chromogenic tests, but also a lot of other possibilities. And we have added a chemiluminescent assay. We have our R&D today working hard to be able to come with new products, with new parameters that will be possible thanks to chemiluminescent module. The clotting technology is actually a little bit improved, We made it dual actually. So we are measuring the clots when we are making chronometric tests. We are measuring it with viscosity-based detection system because it is the gold standard and because it is recognized to have the less interference to optical samples, to hemolyzed icteric or lipemic sample. But sometimes you want to know what happens in the cuvette. You want to see the curve. So we are measuring with a viscosity-based detection system, but at the same time, we are also checking the optical density. So you will get the result with a viscosity-based detection system, and you can add also the kinetic of the curve if you want to have a look to it. We have implemented a chemiluminescent module. Chemiluminescence, the principle is quite equivalent to ELISA methods, but automated. So where you will use magnetic particles coated with either antigens or antibodies. You will put them into the sample, into the cuvette. You wash. You put a new system with light signal, and then finally you measure the light signals. And an important point is that all these tests, whatever viscosity-based detection system, optical, immunoturbidimetric, chromogenic, or chemiluminescence, they are all performed with the one same cuvette. Okay? Meaning the cuvette that you can see here is actually able to perform any kind of test on the instrument. You don't need to load a specific kind of cuvette if you want to perform chemiluminescence or whatever. Just the instrument is capable to manage everything with this one same cuvette, which looks like quite the same than this one, just been modified a little bit to be able to perform also chemiluminescence. Then coming with this new instrument, we have a new dedicated line of reagents. Okay. They come with specific performance, not because the reagents themselves are different, but mainly because the instruments allow us to get more precise results. So we'll get specific performances with this new line of reagents on the sthemO instruments. Okay. And it's always better when it's coming from outside than Stagó to say it. sthemO 301 and 201 has been tested independently at customer site. So there are some literature, some articles that have been published with the first evaluation. And just some few conclusions, some pickup that I took from these articles. The first one coming from Galdacao in Spain, speak about the productivity and say that it's going faster than the StarMax, okay? About depending on the profile, between 30 to 50% faster, okay? And the conclusion is that the 301 is fast, easy to use, and show very good precision. Another poster written by a Dijon customer. Dijon is in the middle, is in France, near Lyon. And saying that actually the throughput is much higher than the StarMax 3, with a decrease of turnaround time of 24% in average, and up to 30% for 100 samples. This was for the 301. For the 201, there was also some few studies, and it is interesting to see that the results, I would say the conclusion are quite equivalent, that the throughput is better than the compact max throughput. And something interesting is that thanks to this new technology that we have on the system, we are able to get a better precision, and especially for the D-dimer, and especially around the cutoff value. So thanks to all this improvement, we are able to come with additional stuff. So, as a conclusion, sthemO is fast, definitely, but it's smart, easy to use, and ready for the future with a lot of technologies that will allow us to come with new features in the years to come. Thank you.